Hello and welcome to Noel's RetroLab. Today we're going to take an Amstrad PPC and turn its display from this to this. After the last video on the Amstrad PPC, I was really disappointed in the quality of the LCD, so I knew right away that I wanted to replace it with a modern LCD. When I started working on this video, I had some doubts on how to go about it. On one hand, I could just do the research ahead of time, go through the different options, pick the best one, and then just present it to you. Here it is, this is the way to do it, ta-da, we're done. Or I could make the video actually looking at the options, evaluating each of them, and then picking the best one. A lot of you have told me that you actually enjoy the journey as much as the destination, if not more. So I've gotten a lot of positive feedback in some of the dead ends that I've gotten to in my repairs, or some of the parts of a project that just don't work out. So I think I'm going to do that in this video, and we're going to go through the process together of replacing this horrible LCD with a modern one. When I started doing research on how to replace the Amstrad PPC LCD with a modern LCD, I found a post by Drygal in 2019 explaining how he had already done it, and he published an extensive blog post with all sorts of details about it. His solution involves using a TV screen of the right size that accepts a VGA signal and converting the external CGA signal into VGA with a converter called MCE to VGA. Great, it's solved, we're done. See you next video. Not so fast. Yes, it's a great start, and the image looks great, and it shows us that it can be done, but it has a pretty big drawback. It's really expensive. The parts used in that mod are an 8-inch LCD TV that can be bought on eBay for £51, or that turns out to be about 58 euros, and the MCE to VGA converter, which is 93 euros, including the FPGA and shipping within the European Union. So it's a total of around 150 euros. You could argue that that's not a lot of money for what you're getting, and you're right, that's a good quality LCD and a great converter, but it's still a lot of money considering the cost of the Amstrad PPC, which probably goes for about 50 to 100 euros these days. So what I'd like to do here is to find a cheaper way to basically implement the same solution. I tried looking for completely different solutions in case there was something much cheaper. I looked briefly at the internal video signal used to drive the Amstrad PPC LCD, and unsurprisingly, I didn't see any easy way to make it work with a modern LCD. So pretty much any solution will involve a VGA screen and a way to convert the external video signal. The first improvement we can do over the original approach is to use a cheaper LCD. Looking around, we don't have to buy a full TV, but instead we can buy an LCD screen with a VGA driver for significantly cheaper. The trick is getting one that is the right size, because we want it to fit right in the frame of the Amstrad PPC. I went ahead and I ordered one that seemed the right size, so let's give it a try. The LCD was 27.86 euros, including shipping. If it works, we'll have saved already over 30 euros with that change alone. So here's the LCD from the Amstrad PPC, and let's see if we can substitute it with something else. This is what I had in mind. This is a modern VGA driven, not exactly VGA input, but you can drive it through a VGA LCD. And one of the most difficult things to get with this particular kind of LCD, well, first of all, is the size, which if you ignore the frame around it, the size seems perfect. And the other thing is that it's a 4x3. There just aren't that many LCDs made these days that are 4x3. They all tend to be 16:9. To fit this here, we're going to have to get a little creative, because obviously we don't have that frame. So we'll have to, when we're ready to do this, obviously once we put it, it's going to look great, but we need to have something to hold it in place. But before I even get into connecting it here, I just want to see that this works. So how exactly is this going to work? So here we have an LCD screen that takes this kind of ribbon input. It also came with this and this. So this connects here, and it just pretty much, I imagine, transfers all the signals to a slightly wider ribbon cable. And then this ribbon cable plugs into here. And then this is the board that drives the LCD, and it takes VGA input as well as HDMI. We don't need the HDMI for anything. So, oh, and maybe it also takes composite, which we don't really want. So first thing we need to do is connect the LCD's ribbon cable to this adapter. So this has one of those slider connectors. I'm not sure what the technical term is. You see those a lot more in modern electronics, like laptop computers and cell phones and things like that. There you go. So just sliding it in, locks it in place. Now we need to connect this to the VGA driver. Okay, so this cable only has connections on one side, the top. Like that. That's as far in as it goes. There you go. So that should keep it in place. Okay. Now that we have the LCD ready, we need a way to convert the CGA signal into VGA, or HDMI in this case. For that, we have several options. The first option is to use the same device as in Drygel's post. We can probably find something cheaper, but that one works and the quality is great. So let's start by trying it. This is a device that I got from Serta Shop, and it does exactly what you imagine. It takes a CGA or EGA input and outputs a VGA signal. So this is perfect to connect to the external signal of the Amstrad PPC and feed it right here. This is by far the easiest solution because we know it works and it's an all-in-one solution. You just plug in the cable, plug the cable here, and it should work just fine. It doesn't take much space. We can easily remove the 3D printed case, although it's a shame because it's really, really cool, but we can just host the board itself inside the Amstrad and it should be fine. So there it is, the CGA connected to the MC to VGA and the VGA cable feeding into the driver board. Now we need to power both those boards. So I have a, I don't know if it's gonna reach, a USB cable for this one. So this is just 5 volts. And then here we can feed 12 volts directly, which is the same thing as the Amstrad itself. So what I'm gonna do is I'm gonna use this splitter on the 12 volts for the Amstrad itself. Like that. Okay, and now we should be ready to test it. Let's see what happens. Okay, this gets powered on. That's good. I just turned on the power, the 12 volts in the bench power supply. I'm going to turn the laptop on. We may have to do something here to tell it to get a signal from the VGA input. I'm not sure. Yeah, we probably need to do something. Oh, there you go. There you go. We didn't even have to do anything. There you go. That's great. Now I'm seeing some flickering here. We saw something similar when I was trying to capture the VGA image. So yeah, this is going to be important to look into this. It could be that it needs the capacitors replaced. I don't think it's the magnet that I put back there, but who knows? It's almost getting worse. It's very, very noticeable. That is not a camera artifact. I'm definitely seeing this myself. That's not flickering. There we go. Beautiful. So this shimmering of text, I just figured out that it's nothing to do with the capacitors and the PPC. It's just part of the conversion from CGA to VGA. So we have some controls here with these buttons. So if we go to phase, there you go. It just went away completely and now it's completely clear and steady, the text in there. So, okay, one last thing that we need to worry about. The total cost for this option would be $27.86 for the LCD and the MC2 VGA is 93 euros, so the total is around 120 euros. Not super cheap, but the quality seems really good. So this approach with the MC2 VGA seems pretty good, but I'm not going to take it any further right now. I think we have other options that are going to be better, and this will become our fallback case in case the other ones don't work out. The next option is to use this board, and it claims to convert CGA, EGA, YUV to VGA. It sounds ideal, right? Well, there are a couple of issues. First of all, what they mean by CGA is not what we mean by CGA, so that's not super helpful. A CGA video signal is a digital signal, meaning that each signal is either low or high. There are no intermediate values. It uses 6 channels and ground. For colors, we have R, G, and B. And if it was just that, since they're digital, it's 3 bits, so CGA would be limited to 8 colors. But we have an extra bit called intensity, which brings the total number of colors that CGA can display up to 16. In addition to the color information, we have 2 other signals. Vertical sync, which is a pulse at the beginning of each frame, and horizontal sync, which is a pulse at the beginning of each scan line. The type of video signal that the GBS 8200 expects is quite different. They call it CGA, but that comes from the Arcade JAMA standard. There's very little documentation out there that I could find, but my understanding is that it expects 4 signals, R, G, and B, but these are fully analog signals, so in our case, each color channel could be low, high, or medium. It also needs a sync signal. This signal has both the vertical sync and horizontal sync combined, and it's negated, so the sync is indicated by the signal going low, not high. So in order to convert our digital CGA signal to an analog one that can be used by the converter board, we need to do a couple of things. Generate an analog RGB signal combining RGB with intensity, and combine and negate the 2 sync signals. What I'm going to try to do is wire the signals from this adapter, so this will plug in our CGA cable right there. I'll have them go to this breadboard. Here we'll do whatever operations we need to do, and then we'll feed those into the RGB inputs of the board. Even initially, just to keep it even simpler, I'm going to ignore the intensity signal from here. So we'll just take RGB, and those we're going to feed straight through. We'll combine horizontal and vertical into a single sync signal, and we'll invert it and feed it into here. And then at that point, we'll see if we get some image on screen. And if we do, then we can try to improve this. Okay, so I've assembled about half the things. I haven't hooked up any of the CGA to VGA board. And I'm going to use this as an opportunity to have a closer look at the signals and make sure that things are doing what we expect them to do. So over here, we're feeding the vertical sync and horizontal sync of the CGA directly from the connector. And I think that's the order anyway. Let's see. Right. So that's the vertical sync. So it only happens once per frame. And then this should happen much more often. Let me make sure I get it right there. Yeah, so that happens once per scan line. So what I've set up here is this is an OR gate, and then we need the negated version of that. So this is an inverter. Normally, whenever I do this for real, I would use a NOR gate. I didn't happen to have any in my stock, so I ended up just assembling the 2 of them, but it's actually nice because we get to see the signal at the ends of both stages. So when we OR them together, what we see here is, there we go. We see pretty much every horizontal sync, and then the vertical sync are those longer gaps in there. And then that output, we feed it into an inverter, and then here we should see the output of that, and it's the opposite. So the horizontal syncs look very similar, and yet the vertical syncs are negated when they're happening and 5 volts all the other time. So now that that's working the way we expect it to work, we can hook it up to the other side of the circuit. Okay, so now we have everything plugged in, the whole sequence. The only thing is that for now, I'm just passing the RGB channels straight through. I am not even plugging in the intensity cable, so I guess we'll only have 2 to the third, so 8 colors. We'll ignore the darker and lighter versions of the colors if all goes well. This is just to see if things work. Okay, so this is actually, I know this is a text. I don't know if you can see it there. There you go. This no signal is coming from here. So hopefully when we turn this on, this will get a signal. Oh, there you go. It went away. Is it already? No, saying no signal. Okay. Usually this doesn't send out any signal until after the beep. There we go. So now, there we go. There we go. We are getting the text. So things are working pretty well. Now you see that the top line is flickering a little bit. I've seen that before with the CGA to SCART. And I've also talked to some other people on Twitter that mentioned that pretty much every Amstrad PC outputting CGA that they have has that weird flickery thing. So it may be like some weird way that Amstrad generates the signal. Apparently that's rock steady with the Amstrad monitor, go figure, but when you output it to some other kind of external CGA, you get a little bit of that. So we may have to live with that. So that looks pretty good. First try too, so that's great. So now that I have this bare bones stuff working, let's have a closer look at the signals. So I wanted to look at the sync signals a little bit more closely. So let's start with the vertical sync. There we go, that's what we saw earlier. But I noticed there's those little lines in there, and yeah, as we zoom, they're pretty noticeable. And let's see if they're also present in the horizontal sync. Yeah, look at that. Look at that, they're very noticeable. So I have a theory about this, and that is that might be the color signal interfering with the sync signals. Now, if that's the case, that wouldn't be surprising at all. This is not how you're supposed to run video circuits like this. We are taking unshielded cables, going through a breadboard and more unshielded cables. So this is horrible. This is just proof of concept, but it could be bad enough that it's preventing us from getting a stable signal. So one thing I can do actually is I can try overlapping that signal with one of the colors. Let's look at one of the color signals. Okay, so it's a bit of a mess here with all these cables, but I have the second channel hooked up to the red signal, and so that's the blue one in there. That's why you see it, yeah, spike like that every so often. And with this one now, I'm going to look at maybe the horizontal sync. And yeah, okay, I'm gonna try to do a single capture until I catch one like that. Look at that. So this was a scan line that obviously had some text. The RGB one is displayed, well, the R channel, but it's gray, so it would be the same in all of them. And then the horizontal sync has that amount of noise. I wouldn't be surprised if that noise is introduced purely by our circuit right here. It could be interesting to then unhook everything and look at it directly on the PCB, or even just unhook everything and look in the cable itself. The cable, this is shielded, so we shouldn't have that kind of interference. So that's actually pretty interesting. And that could definitely explain why we're seeing the problems we're seeing. Actually, if that's the case, the more color, the more text, the more color signal that we have on the screen, the worse it should get. So let's try adding more text to the screen and see if the signal becomes less stable. Okay, so let's see if having more text on screen, that will have more information in the color signals, and let's see if that interferes at all with the sync signals. So maybe I can just Do that. Oh, yeah, look, wow. Yeah, so as we had more text, started losing sync enough that now it's not even able to sync to it at all. So if I clear the screen, just type CLS. There we go. Oh, and okay, this is something I've seen before. This is not anything to do with the circuit right here. It just happened to do it right now. There is something wrong with the, I imagine, the driver of this particular LCD screen that every so often it flips everything horizontally. So yeah, it's saying A and it's mirror there. So even if I unplug it somewhere, it will say no signal. So just so you can see that it's not related to that. I'm gonna unplug it right here. It will probably say no signal. Yeah, and it's actually mirrored. And it just eventually goes away and it becomes unmirrored. So in the meanwhile, I've ordered another LCD driver board. So to replace this one, hopefully we won't have a problem because the LCD is ideal. I love the image quality, I love the size, but yeah, we're getting this weird flipping mirroring issue. So when I get a new one, I'll definitely show it, and I will put a link to the vendor, assuming that it works correctly, to the vendor that I got it from. So I wanted to take advantage of having the board open right now to look at the video signal without any cables. So this is how it ideally should look. And I believe those three are R, G, and B. Yeah, there you go. So we're pretty zoomed in, so we get the occasional line because we only have a couple of lines. And then if we look at this vertical sync, horizontal sync, yeah, look at that. There's no hint of noise. Maybe there's a tiny little hint of noise in there, but nothing like before. If I zoom in even more, yeah, not even a hint of noise. This is a very clean, square pulse. So we were introducing all that noise because of our cables and breadboard enough that the poor board wasn't able to sync to it. So that's a good lesson to learn with video signals in general. One of the problems I need to solve, no matter what approach I use, is where to fit the parts. Fortunately, the Amstrad PPC had a case with a lot of extra room for accessories. So one of the places that we can consider is the battery compartment, since I'm not planning on putting any real batteries there, and that's pretty roomy. The other place is actually, I think, where the modem was intended to go, which is under these drives, and even something this wide, which at first I thought I couldn't use it. I guess it would fit there pretty well. I just need to run cables from the board with the video signal to here, and then from here to the LCD over there. So, there's a few cables running through, but it's a reasonable place for it. Let's look at how much room we have there exactly. So you can ignore this wire. This is where I was getting the 5 volts for the breadboard. But yeah, this might not be as much as I thought. I was assuming that we had all this much when I was looking at it from above, but no, the board sticks all the way to here. So yeah, this might be a really tight fit or not fit at all. Yeah, that's what I was afraid of. And that's why I wanted to check right now before we spend a lot more time with this solution trying to shield the cables and trying to get everything just right, if we're not going to be able to fit it in the end. And this definitely does not fit in the battery compartment. The battery compartment is about this tall. So yeah, we may have to look at option 3. I think we could have made the GBS 8200 approach work had it had a smaller footprint. The GBS 8200 converter has been around for a long time and it's cheap, but it doesn't have a great reputation as far as quality goes. However, there are some recent projects like the GBS Control that provide a few mods and a new firmware to really improve the quality of the conversion and offer less lag. So if you're dealing with a similar project and are able to use the GBS 8200, definitely check out that project. As far as cost goes, it was a pretty cheap option. The GBS can be found for 1650 euros shipped, so that brings the total cost down to 45 euros. Those are huge savings over the original setup. I think the MCE to VGA option is our best bet so far, but there's still a third option that I want to try. That one is going to take a little longer, and I don't even have the PCBs here, so we're going to save that for our next video. I think once we fit everything inside the case, it's going to turn this Amstrad PPC into a really fun little CGA computer, so I'm really looking forward to seeing that. Anyway, I hope you enjoyed this episode. If so, please give it a thumbs up and subscribe to the channel. Until next video, see you then. If you enjoyed this video, please consider supporting Noel's Retro Lab on Patreon or joining the membership on YouTube. Not only is that the best way to support this channel and allow me to continue making more videos, but you also get some extra perks like early access, ad-free videos, and more. Thank you again to all the supporters. See you next time.